Traditional scheduling methods like bar charts are useful, but limited. They don't show how tasks depend on one another. That's where network planning steps in, offering a complete picture of task flow and interdependencies. Network diagrams provide a visual map of your project. You see what must be done, in what order, where risks and delays can occur. It's your tool to plan proactively, not reactively. Every network has 4 basic elements. Events, these are milestones or checkpoints. Activities, the actual segments of work being done. Duration versus effort. Duration is the time something takes, while effort is the actual amount of work. And the critical path, the longest path through the project. Managing the critical path is key to keeping the project on schedule. As shown in figure, events are circles and activities are arrows. The direction of arrows shows sequence, and the numbers show duration. This structure helps identify the earliest and latest possible start times for every activity. You don't need to start from scratch. This figure shows how. A Gantt chart can be converted to a milestone chart, and a milestone chart can be converted to a PERT chart. You move from static schedules to dynamic, dependency-based control. This table shows the sequence of events in a project. Large projects can be easily converted into PERT networks once a few simple questions are answered. First, what job immediately precedes this job? Second, what job immediately follows this job? And third, what jobs can be run concurrently? These questions help define the sequence and flow of work, and that's all you need to start building the PERT network. The figure on the right shows a typical PERT network. The bold line represents the critical path, which is the longest time span through the entire network. In this example, the critical path goes through events 1, 2, 3, 5, 6, 7, 8, 9. The critical path is important because it tells management 2 key things. First, there is no slack time on this path. So, any delay in these events will directly delay the project, unless the lost time can be recovered later on the same path. Second, these events are the most critical for the project's success. Management should focus closely on them to improve overall performance. Using PERT, we can also identify the earliest possible dates that each event can occur, or when an activity can start or finish. The principles we've discussed so far also apply to critical path method, CPM. The terminology is the same, and both PERT and CPM are often called arrow diagramming methods or activity-on-arrow networks. The main differences are: PERT uses 3 time estimates, optimistic, most likely, and pessimistic, to calculate an expected time. CPM, on the other hand, uses just 1 time estimate, the normal time, which usually gives better accuracy.